Afternoon, everybody, and here are the answers for the 6 questions I set this morning. So, question number 1, 6.5, add 0.019. So, put it into a formal method and then line the dots up, decimal points. So, as you can see, 0.019 is a slightly longer number, as you can see, when you put them into a formal method, so you need to make sure that you put your placeholders in to make it easier for yourself. And we start adding from the right hand side, the smallest digit. So 0 plus 9 is 9, 0 plus 1 is 1, 6 plus 0, 5 plus 0 is 5, drop the dot all the way down, and 6 plus 0 is 6. You've got 6.519 as your answer. For question number 2, 700,000. So a large number, 6 digits, this number. So 700,000, and you're subtracting from that number 3,459. Okay, so I'm going to use the formal method here again. Easiest way for me to work out the answer, and again I start subtracting from the smallest digit. So 0 take away 9, we can't do that, so we've got to borrow from next door. There's nothing there, so we continue to keep borrowing until we get to a digit where we can actually exchange a number. So 7 becomes a 6, that 0 becomes a 10, we've got to borrow another one, so that becomes a 9. This one here becomes a 10, borrow another, so as you can see, the numbers are filtering down the line. This one becomes a 10, take one away, becomes a 9. Okay, and we've just got to do it one more time, and then finally we get back to our original two numbers that we are going to subtract from each other. So now you can do it. 10 take away 9 is 1, 9 take away 5 is 4, 9 take away 4 is 5, 9 take away 3, 6, 9 take away nothing is 9, and 6 take away nothing is 6. Little trick of how to chunk these numbers so you can pronounce the number easily. If you start from the smallest digit and count 1, 2, 3 numbers in and put a comma in front of the third digit, that then can chunk your number, so you've got 696,541 as your answer. Question number 3. So you're multiplying this number 3.02 by 100. So I write my original number 3.02, and then I'm going to use my dots method to work out the answer. So in 100 there's 1, 2 zeros, so I'm going to put 2 dots below the original decimal point, and then because I'm multiplying, I'm making the number 100 times bigger, so that means I need to move the numbers to the left. So I move it once, becomes 30.2, then I move it again, and then it becomes 302. So 302 is your answer. Okay, question 4, we've got 84.1, subtract 6.77. So I'm going to use my formal method again, just to clearly show the, so you see there, it's really important for me to line the decimal points up, because that's what can happen. 6.77, then I need to put my placeholder in. So starting from the smallest digit, 0 subtract 7, can't do it, need to borrow. Take 1 off, it becomes a 0, this becomes a 10. 10 take away 7 is 3. 0 take away 7, we can't do it again, so we've got to borrow from here. This becomes a 10. 10 take away 7, again is 3. 3 take away 6, can't do. So we exchange 1. 13 take away 6 is 7, and 7 take away nothing is 7. Now, there's something that I've done here which is going to affect me getting the correct answer or not. And that, what I haven't done is I haven't dropped that decimal point down. That's really, really important. So 77.33 would be your answer. Okay, 4/5, take away 1/3 problem. Well, denominators are different, so we need to make them the same. So I'm going to multiply the 5 by 3. That gives me 15. And then I'm going to multiply the 3 by 5, which also gives me 15. And that now makes the denominators the same in both the fractions. However, whatever I do to the bottom, I must do to the top. So I've multiplied the 5 by the 3, so I must multiply the 4 by the 3, which gives me 12. And I've multiplied the 3 by the 5, so I've got to multiply the 1 by the 5, which gives me 5. And remember that the operation that we're using is subtraction. So then I subtract the two numerators. 12 subtract 5 is 7. And the denominator stays the same. So 7/15, 7/15 is the correct answer. Okay, so finally, moving on to this final question, 8,241 divided by 67. So I've got to see how many 67s are in 8,241. So currently, I look to see how many 67s are in 8. So well, there are 0 67s in 8. How many 67s are in 82? Well, I know that I can definitely fit one 67 into 82. However, what I need to do is put that 67 then below my 82, and I need to subtract it away. So 82 subtract 67, start subtracting from the smallest digit. 2 take away 7, I can't do, so I need to borrow from here. That becomes a 7, this one becomes a 12, so 12 take away 7 is 5, and 7 take away 6 is 1, so I'm left with 15, and I'm going to drop that 4 down here to make 156. So then I see how many 67s are in 154. Okay, so doing my 67 times table, very tricky, so I must move over here and then look at my partitioning method to do my 67 times table. So in this column here, we're going to do our go up in 60s, and here we're going to go up in 7s. So all I need to do is go up in 6s and add my 0 at the end. So 6, 60 comes next, 12, my 0 on the end, 18, my 0 on the end. Okay, and then I need to add the 1s to my 10s column, because that will then give me the next multiple of 67. So 7, 14, 21. And the reason why I've stopped there is because I'm looking to see how many 67s are in 154. And I know that, well, 180 is obviously larger than 154, so I'm going to stop there so I can continue to work out my answer. So if I add these two numbers together, that then gives me my multiples of 67. Ooh. Okay, so I can see that there are 1, 2 67s in 154, and I end up on 134. So I need to put that number below 154 and again subtract it. And the reason I do that is because that will then give me my remainder. So 4 take away 4 is 0, 5 take away 3 is 2, and 1 take away 1 is 0. But I'm not going to put the 0 there, I'm just going to leave it as it is. And then I'm going to drop my final digit all the way down to make 201. Now I refer back to my multiples, and I know that I've ended up on 201. So that then gives me a really good indication that there's not going to be a remainder in this number. So how many 67s are in 201? Well, there's 1, 2, 3, without a remainder. So my answer is 123. Okay, here are all of the answers. There's a summary of the answers. Go back through your work, see if you've got the correct ones. If any are incorrect, make sure that you go through my workings to see where you might have gone wrong. I'm just going to flick back to this question here. Now, long division can be quite tricky because there's quite a few steps that you need to go through in order to get the correct answer. And I understand that when you've got a two-digit number, working out its multiples can be quite tricky, especially when you've got a big number like 67. So this partitioning method is really, really effective. And it's a method that any child, any adult can use in order to get the multiples of a larger number. So although it's quite time consuming, the more that you do it, the quicker you'll become, and you'll be able to tackle any long division question that you're faced with. Okay, guys, so that's a really important skill to know. All right, hopefully you got 6 out of 6. If you didn't, doesn't matter, because you learn from your mistakes. That's the best way of learning. Hope you enjoyed those 6, guys, and I'll see you tomorrow morning for another 6. Take care. Bye.